Breeann and I'm a math resident at your school. So what that means is I'm not a teacher, but I'm actually an expert in mathematics. So I can answer any questions you have, I can help you with your homework, and hopefully I'll be showing you some really cool new stuff about math this year. My research area is graph theory. So what that means is if I have, let's say, 4 houses and there's 7 streets between them, I ask the question, if I start at one house, can I go along all of the streets, visit all of the houses, and end up back at the house that I started with? If I can do that, then the question I would ask from there is, if I have more houses or more streets, can I do the same thing? If I can't do the same thing, then I ask the question, why? What about these streets and houses is not letting me do that? So I'm working on a PhD in math, in graph theory, and what that means is you have to prove something new about math that's never been proven before. It's going to take me a long time, and afterwards people will have to call me Dr. Thompson. Okay? I love math, but there's also a lot of other things about me that I'd love to talk to you about. For example, I love Twilight. I consider myself a member of Team Edward. I also love Harry Potter, pretty much because when I was in middle school, I was a lot like Hermione. I know, teacher, please call me. I have the right answer. So I also played soccer in high school and in college. I ski. Every year I get a season pass to Copper in Winter Park. So I'd love to talk to you about any of these things this year, and I can't wait to meet you all. Thanks. All right, here's a math activity that I thought you might find interesting. I have in front of me 2 strips of paper, some markers, some tape, and some scissors. Okay. What I'm going to do with the first strip of paper is I'm just going to go ahead and tape it together in a loop that you've probably seen lots of times before. Okay. I've already done that here with this loop. Okay. I'm going to go ahead and explore the loop, see how many sides it has. I'm going to take my pink marker and go ahead and start on the outside. You may not be able to see this too well, but as I draw along the outside of the marker, the outside of the loop with the marker, I eventually get back to where I started. Okay? So I've just drawn all the way around on the outside of the loop. But I haven't drawn on the inside of the loop at all. Okay, so I'm going to go ahead and...
as you can probably predict, I'm going to end up meeting where I started with the blue marker.
Okay, so all that we're seeing about this is there's 2 sides. There's an outside and an inside, or, as you might be able to see, a pink side and a blue side. Okay? So now I'm going to take my second strip of paper, and instead of connecting it like I did the first time, I'm just going to go ahead and put a little twist in it and connect it like this.
Yeah, I already done this over here. But again, I'm going to explore how many sides does this have. Again, I take my pink marker, and I go ahead and I start going along the outside, drawing on the loop. Okay, kind of tricky, that's what you kind of have to do. But I keep going. Keep going. Oh my goodness, I've been drawing for a really long time now.
Keep going. Alright. Okay, so what ended up happening is I hit where I had originally started with the pink marker. I went all the way around, front and back, as you can see, front and back, and all with pink. So what that means is that there's only one side. Where there is a pink side and a blue side on this strip, there's only one side in this strip. Which is crazy, right? Okay, this was actually discovered by 2 mathematicians. One of them was named August Mobius, and so this is actually called a Mobius strip, or a Mobius band. Only has one side. Kind of crazy. Now what we're going to do is we're going to cut them. Okay? So I have like I showed you, a pink line down the center. I'm going to go ahead and just cut along that pink line. See what happens. As you probably predicted, I have 2 separate loops. So I'm going to do the same thing for my Mobius band. And you should be asking yourself right now, what do you think is going to happen? Am I going to have 2 separate ones? Let's see.
I cut a little, and then I cut around. This Mobius band thing is actually a part of mathematics called topology. It's a very cool area of mathematics. Studies things like that.
Alright, so what happened? Instead of getting 2 separate circles, I got one big loop. Pretty cool. But now, I'm going to ask the question. I have another Mobius band here. I'm going to go ahead and instead of cutting it in half, I'm going to cut it in thirds.
To see what happens. So I start, keep the blue on this one, and I start about where a third would be, if they ask me, and start cutting around the outside of the circle. Doesn't have to be perfectly straight. That was the way I started cutting, but I'm on the other side. I'm just going to keep cutting into the thirds like I had before.
Okay, so right now you should be asking yourself, what do you think is going to happen? Am I going to have one loop? Am I going to have two loops? What's going to happen? The answer to that question is, I have two loops, okay, that are interlocking. Okay, it's pretty cool. So now, the next question you may be asking yourself is, what happens if I connect it like this, and instead of putting one twist, I put two twists? So I want you to do that and explore that and see what happens. Okay? Math is a pretty cool subject, and you may be wondering why these things end up like this. And what I want you to do this year is I want you to come ask me, and I'll be happy to talk to you about it. Math can be predictable, math can be surprising, but it's pretty cool and powerful, and I can't wait to explore it with you guys this year.